Welcome back to this channel. In this video, they are requiring us to find the missing sides. So we have this right triangle, and inside it, we have two right triangles. This is 90 degrees. This is 90. So it implies that also this is 90 degrees since this is a straight line. So this here is also 90 degrees. So it's a right triangle. This inside is a right triangle. Also this one is a right triangle. Well, from here to here is 9, and from here to here is 16. Do not mind about the scaling. The drawing is not to scale. So don't say it doesn't look proportional, it doesn't look like what you say it is. So from here to here is 16, though this looks longer than this, but you get the concept. So from here to here is 16, and from here to here is 9. So we are required to find this side, the length of this side, and then the length of this from here to here, and this length or the height of this outer triangle. So let's start by labeling the diagram. Let this be M, N, and let this be P. Okay, let's call this point D. So now from the right triangle altitude theorem, the altitude to the hypotenuse of a right triangle forms two triangles that are similar to each other and to the original triangle. So if you have something like this is 90 degrees, and then this is 90 degrees, this is M, this is N. So if you have a right triangle and inscribed inside it is also another right triangle, and we have this side as M and then this side as N, and this is the height H, this is the height H is from here to here, then H is equals to root of MN from this. So going back to our diagram, if this is H, dN is H, then H will be equals to, we've said it's root MN. So our M in this case is 16 and our N is 9. So H is equals to 16 times 9 is 144. So H is positive or negative 12. But since H represents length, it cannot be negative. So we consider only the positive. So H, which is dN, is equals to 12 units. Okay, so we've been able to find dN so far. Next, let's focus on this triangle MDN, this one here. We can see that MD is 16, which is 4 by 4. Okay, and we have found dN to be 12, which is the same as 3 by 4. So as you can see here, 4 is common, so that means 4 is the common multiple. So this is 3, this is 4. From Pythagorean triples, we can conclude that this is a 3, 4, 5 triangle, because it's the closest to that in the Pythagorean triples. So since now the common multiple is 4, so that means that also this side MN will have a 4, which is common. So it's a 3 to 4 to 5. So it will be 5, 4. So MN is 5, 4, which is 5 times 4 is 20. Therefore, side MN is 20 units. Next, let's focus on this triangle NDP, this one here. We can see that this side is 12, this side is 9. So 12 can be the same as 3 by 3, and 12 could be the same as 4 by 3. So as you can see in this triangle DPN, we have the common multiple as 3. That implies that also this side PN will have a common multiple of 3. Now to get the other figure, we go back to our Pythagorean triples this side. So we have 3, 4. So the closest to that is 5. So it's a 3 to 4 to 5 triangle as well. So this will be 5 by 3. Therefore, PN is 5 by 3. 5 times 3 is 15. So this side PN is 15. So we have been able to figure out all our missing sides. Side MN is 20 units. Side DN is 12 units. And side PN is 15 units. Okay. Let's look at method 2 that you could have used to solve the same. So let's take it that we don't have all these. Okay. We do not have all these. This is 16, this is 9. Okay, and we're looking for this side, and this side. So in method 2, we are going to say, let this side here, let MN be X, let DN be Y, and let PN be Z. So first focusing on triangle MND, which is like this. This is 90 degrees. This is DMN. This side is 16. DN is Y and MN is X. Since it's a right triangle, we can use Pythagoras theorem to solve. So according to Pythagoras theorem, a squared plus b squared is equals to c squared. So our A is 16, this side empty, so 16 squared plus our B is Y is equals to our C, which is X squared, since it's the hypotenuse. So we make this the subject, so we shall have X squared when this crosses becomes minus Y squared is equals to 16 squared. So X squared minus Y squared is equals to 16 squared is 256. Let this be equation 1. Next, let's focus on this triangle PDN, which is like this. So this is 90 degrees, this is D, this is P, and this is N. PN is Z, DP is 9, and DN is Y. So it's also a right triangle. We can use Pythagoras theorem. So a squared plus b squared is equals to c squared. Our a, in this case, is 9. So 9 squared plus our b is y is equals to our c, which is z squared. So we take the y squared the other side. So we shall have z squared minus y squared being equals to 9 squared. So z squared minus y squared is equals to 81. Let this be equation 2. Next, focusing on the outer triangle MNP. So it's also a right triangle. So a squared plus b squared is equals to c squared. Our a is x. So x squared plus our b is z squared is equals to our c is 16 plus 9, which is 25. So 25 squared. So we have x squared plus z squared is equals to 25 squared is 625. Let this be equation 3. So now we have come up with three equations. The first equation was x squared minus y squared is equals to 256. The second equation was z squared minus y squared is equals to 81. And now the third equation is x squared plus z squared is equals to 625. So we come up with a system of simultaneous equations. So for us to be able to simplify this, we are going to say let u equals to x squared, then let v equals to y squared, and let w equals to z squared. So now these equations will become u minus v is equals to 256. Then the second one will become w minus v is equals to 81. Then the third one will become u plus w is equals to 625. So this is our equation 1, equation 2, and equation 3. Now from equation 1, when we make u the subject, u will be equals to 256 plus v. So let this be equation 4. Now from equation 2, w will be equals to 81 plus v. Let this be equation 5. Now let's substitute 4 and 5 into 3. Let's substitute for u and w into this equation here. So we shall have u plus w, which will become 256 plus v for u, then plus 81 plus v for w. This is equals to 625. Okay, so this becomes 256 plus v plus 81 plus v is equals to 625. So 256 plus 81 gives us 337. V plus v gives us 2v. This is equals to 625. So 2v is equals to 625 minus 337. 2v is equals to this gives us 288. Divide both sides by 2. So v is equals to 144. So we have found the value of v. Now from my equation 4, we had that u is equals to 256 plus v. So we have the value of v, so we substitute. So u will be equals to 256 plus 144. And therefore u is equals to 400. And also from equation 5, we had that w is equals to 81 plus v. And we have found v, so w is equals to 81 plus 144. And therefore w is equals to 225. Now that we have found the values of u, v, and w, we can now solve for x, y, and z, since u, v, and w were representing values of x squared, y squared, and z squared. So we said that u is equals to x squared, then v is equals to y squared, and w is equals to z squared. So this implies that for the first one, x squared, we got our value of u as 400. So x squared is 400. So x will be equals to square root of 400. And therefore x is equals to, we cannot take negative value because x represents length. So x square root of 400 is 20. Therefore x is 20. Then, so we are getting that x here is equals to 20. Then y squared, we've said, is equals to v, and we got our v value as 144. So y is equals to square root of 144, take positive value, which is 12. So y here is 12. Then z squared is equals to w, and we've got the value of w as 225. So z is the square root of 225. So z is equals to positive 15. So here, this is equals to 15. As you can see, even in this approach, we have got the same values as we got before. So this is 20, this is 12, and this is 15. So those are the missing sides. Well, there is another method 3. Let me show it to you as well. So in method 3, let's take it that we don't have all this. Sorry for the disorganization. But yeah, so we are taking it that we don't have any of the values. So we are looking for this side mn, dn, and pn. So first, let's consider this triangle MND, this one here. So this is 90 degrees. Let this angle be alpha, and this angle here, beta. Now, since this is 90 degrees, that implies that alpha and beta are complementary angles because they add up to 90 degrees. And we know that interior angles of a triangle must add up to 180. So if this is 90, that means that these two share 90 degrees. So they are complementary angles. So next, let's focus on this triangle NDP, this one here. Since this is 90, this is also 90 degrees. And since this is 90, this angle here is beta. That implies that this angle, because it's 90 degrees and this is beta, it implies that this angle is alpha, because alpha is the complement of beta, as we have already seen. Now that this is alpha, this is 90, that implies that this is beta, because it's the complement of alpha. So that implies that this triangle here, MND and PND, this triangle and this triangle, it implies that they are similar. Since they are similar, we can use proportions. So using proportions, we can say that PD over, so PD over DN is equals to DN over dm. Okay, so this will give us dm times pd being equals to dn times dn. So we shall have dn squared being equals to dm times pd. So find the square root on both sides. So dn is equals to root of dm times pd. So this here proves our, if you remember our equation that we had, which was h is equals to mn, where this was h and this side from here to here is m and from here to here is n. So our dn is the h is equals to dm or md times pd here. Therefore, dn is equals to square root of dm is 16 times pd is 9. So dn is equals to square root of 144 And so dn is 12, positive of course. Now considering this triangle, MDN this is 90 degrees, this is DMN, this side is 16, this we've got it as 12, so this is the same as 4, and this is the same as 3 by 4, so 4 is the common multiple. That implies that also this side will have a 4. So that means the differing figures are 3 and 4. So from our Pythagorean triples, since this is a right triangle, from Pythagorean triples 3 to 4, the closest to that from the table is 5. So this side will be times 5. Therefore, Mn is 5 times 4, which is equals to 20. So far we have this side is 12 and this side is 20. Next, let's focus on triangle DNP, this one here. So this is 90 degrees, this is DPN. This is 9, this is 12. So 9 can be written as 3 by 3 and 12 can be written as 4 by 3. So 3 is our common multiple. So this side will also have a 3. Now, looking at the differing figures 3 and 4, since it's a right triangle from our Pythagorean triples, 3 to 4, the closest to that is 5. So it's a 3 to 4 to 5 triangle. So this side will be 5. So 5 times 3 is 15. So side PN is 15. So you can use either of the 3 methods to solve for the missing sides. Thank you so much for watching. Kindly subscribe to this channel for more amazing videos. Like, comment and share your thoughts about this video in the comment section down below. Also, you can correct me where I've gone wrong, and do not forget to share alternative approaches if there are any that I haven't mentioned. You can share them with us also. Thank you so much. Please subscribe, it's free of charge. Thank you. Let's meet in the next video.